When a T-SQL statement gets submitted to SQL Server, it goes through multiple steps before we get the final output. Let's have a look on SQL Server Query execution architecture to understand this. Remember that the optimization process applies to the DML statements only. DDL and DCL statements get submitted to the storage engine directly after parsing. There are two major components of SQL Server which are responsible for query execution: Relational Engine and Storage Engine. Relational Engine accommodates three major components: Parser, Algebraizer and Query Optimizer. If the given T-SQL statement is a DML statement, Relational Engine checks the syntax, resolves names, identifies aggregates and generates a good enough plan for the given query and submits it to the storage engine, which actually executes the query. But if the given statement is DDL or DCL statement, Relational Engine parses it and checks for syntax and directly submits it to the storage engine, as DDL and DCL statements do not follow the optimization process. Let's discuss each component and their roles in more detail. Imagine this arrow represents SQL Server Query execution pipeline. Now we will input our T-SQL statement in this pipe. Here we are submitting the T-SQL query. First of all, the parser comes into the scene, which parses the given T-SQL statement and checks for the syntax. If the syntax is correct, it generates a parse tree, and depending on the type of statement, it sends it to Algebraizer or storage engine. In case the given statement is DML, it sends it to Algebraizer, and in case of DDL or DCL, it sends it to the storage engine directly, because DDL and DCL statements do not follow optimization process. Algebraizer is responsible for binding objects. It resolves all the names and determines aggregates and generates a binary tree and pushes it to the Query Optimizer. Query Optimizer is responsible for creating a good enough plan instead of maximum performance plan to execute the given T-SQL query. SQL Server Optimizer is a cost-based optimizer. Based on statistics, it generates multiple plans if no plan is found in plan cache for the given query, and chooses the lowest cost plan from the generated plans. There are some thresholds to recognize the limits of number of generated plans and types of plans, like whether it should be executed with single processor or using multiple processors using parallelism. Query Optimizer also stores the plan in plan cache if no identical plan exists there. Parser, Algebraizer and Query Optimizer are the components of Relational Engine, and at this stage we get the estimated execution plan for the query. This estimated query plan gets submitted to storage engine, which actually executes the query using physical operators. And here we get the actual execution plan. In most of the cases, the actual plan and the estimated plan are same. But sometimes, like in case of deferred plans, storage engine may decide to use a different plan during actual execution. And if this happens, we get different actual plan than estimated plan. Finally, we get the output here. We can see that Relational Engine, which is optimized to deal with sets, plays a major role during execution plan generation, and that is why understanding set-based approach is important. In next section, let's understand how joins work in SQL Server, which will help us to build a strong foundation for set-based approach.